Thanks, Justin, and thanks to Cortex for having me here. So I'm going to talk a little bit about engineering paved paths for a user-friendly developer platform at the New York Times. So I'm sure folks are familiar with the Times and our brand, but before we start, I just want to tell you a little bit about what we do, in case you don't know. So we seek the truth and help people understand the world, and we're doing that by aiming to build the essential subscription bundle for every curious person who seeks to understand and engage with the world. And I think the news product is our most common and probably the most recognized product, but there are other things that the Times does and has grown in the last few years, specifically with things like games. After acquiring Wordle, we built some new exciting games like Strands, and there's a new game coming out that's in beta now. If anybody lives in Canada, you can access it. It's called Zorse. And then we also have cooking and two other products, Wirecutter and The Athletic. The Athletic is a sports journalism website that folks may be familiar with. So this makes up sort of our bundle and our larger brand that our users are interacting with. And we're trying to build a platform for all the engineers that work on all of these products. So next we're going to see sort of a video. This is a scrolling thing that we did on the website. But the Times is attempting to be a digital-first experience, right? This is a rendering of the Maui wildfires drawn on Google Earth. And within this, there's video and text and images and lots of stuff that goes into building these stories. And we're trying, like I said, to build a platform that allows the newsroom to really focus on building these types of interactives and doing journalism without having to worry about how these things are deployed and monitoring them and running them in our production systems. So this is a rundown of what I'm going to talk about today. I'm going to talk about our internal developer platform. I will mention why it doesn't say portal in a few minutes. Then I'll talk a little bit about the platform architecture. This is a little bit more, I think, technical than the talks have been so far today. I'll go over some of the tools and technologies that we're using, some of the choices we made, and as to why. And then I'm going to end with sort of platform as product, talk a little bit about our sort of product management viewpoint and focus, how we're trying to cross the quote-unquote chasm by getting to majority adoption, and then wrap up with lessons learned. So first, what is an IDP? So an internal developer portal versus a platform, I think from our perspective, is a centralized platform designed to improve developer productivity and experience of development teams within an organization. And it's sort of made up of maybe a few things. There's probably lots of things that could go into a portal, and I think some of these have been touched on today already. So self-service infrastructure is a big one. We want developers to be able to go someplace and not have to create tickets or bug somebody when they need a new development environment. A service catalog is also very important. We don't want spreadsheets like we saw in one of the earlier talks documenting all the systems. Documentation is something that I've been particularly interested in lately. Just discoverability and documentation is generally spread out all throughout a company, whether it's wikis or GitHub or make docs pages. And then lastly, just general tooling and automation that may be outside of the regular development flow of a developer. We're going to one single place to find those sorts of things. So at the Times, as I mentioned, we're focused on maybe a little bit more of the platform side of this first than the portal. So we're really designing a platform that offers a set of tools and capabilities that any developer at the Times can use to accelerate their work. And this aligns with our enterprise goal of using technology and data to propel our growth. So Justin showed a slide earlier of the CNCF landscape and also this sort of DevOps cycle. And I think I'm going to touch on that a little bit here as well in a different way, which is that the ideal state of an application developer is to write code, develop their application, and implement best practices within that application. But really, their life looks a little bit more like this now, which is they're focused on not only developing, but they've got all these other paradigms that they have to keep track of, right? They've got to know how to containerize their app, which deals with writing a Docker file maybe, but also what registry do they use, how do they publish it there. They've got to worry about how to provision their application, but maybe also code, so things like infrastructure as code. What orchestration systems do they use? Then they've got to worry about writing pipelines to build, test, and deploy their app. How do they deal with authentication for where they're pushing their artifacts? What type of deployment style do they use? Some applications may need to be in multiple regions, deal with business continuity planning, all of that. how do they route traffic to their application? How do they get a certificate? How do they make sure they've got WAF rules in place and are protected against DDoS? So all of that ingress logic needs to be handled by someone. And then lastly, monitoring, which is could be a whole talk in itself of how do they deal with metrics and traces and logging, what systems do they use. Most companies have a centralized logging location, but each software development language has different SDKs and tools to sort of implement all that. And it's changed so much over the last couple of years, where do they start? So, we're trying to really keep the state here, not have them worry so much about all those other things. So let me talk a little bit about the platform architecture and sort of how we're trying to accomplish that. So the first thing is really looking at the runtime. And oftentimes, and I think in my past, runtimes often look like this, where you have feature teams and maybe DevOps engineers embedded, where they're running some type of containerized runtime. And in this case, it's shown as Kubernetes, where they may have a team doing something with a cloud provider like GCP or AWS. You may have teams running Kubernetes on-prem. You may have one team running Kubernetes and another team running ECS or another team running Fargate. And I've definitely seen that at larger companies where everyone sort of has their own style based on budget or what some developer may have a preference on. For us, we're really trying to consolidate all that down to a set of shared clusters by environment that a team inside of the Times manages. Our team happens to be called Delivery Engineering. And this sort of abstracts away what the runtime is for people. So all they have to worry about is my app containerized? Okay, it can run on the platform. And then we provide a sort of set of environments for them to use that we call dev stage and prod, which are sort of generic names. I think you may have a QA one, you may have, I've heard UAT in the past, depending on your company and what your needs are. And this is sort of an animation of sort of the different components we're offering. It doesn't represent the flow perfectly, but it shows sort of an overall system of what we're building. So you have NYT engineers on the left and end users on the right. So the first thing is really how do they create a new app or onboard to the platform, whether they have an existing application that may be running somewhere else or they want to get started new. You need some place to store that, some source control repository, whether it's GitHub or GitLab. You have a set of CI/CD tooling that deals with build, test, and deploy. You have a runtime, which I mentioned in our case is Kubernetes, and then you have some cloud provider that either hosts that runtime, but also may host things like databases and other managed services. And then lastly on the end is some type of ingress layer dealing with traffic routing, WAF, DDoS, all that stuff I mentioned, caching. And then on the bottom, sort of underlying all of this is some observability framework dealing with metrics and traces and monitoring, collecting it, visualizing it, building dashboards, all of that. So I'm going to focus on sort of each of these pieces individually and talk a little bit more about how they work and what the goals are. So the first one is really the create and onboard. And that looks at this sort of goal, which is lofty, I think, and we're not fully meeting it now, but we attempt to. So the goal is to build fully functional services running in production on day 0 in under 10 minutes. So the goal is the developer can come someplace, say, I want a new service written language X, and they should be able to get that running in production in 10 minutes. And there's some caveats to that is there's still some manual gates in our process that require access to cloud accounts. But for the most part, this is true. They can fill out something, form, which I'll talk about, and they'll get everything that they need running in Kubernetes out of the box for them. So the goal of this sort of template engine is to have this set of included capabilities on the left, and then user-provided things on the right. So the included capabilities are really source control setup, source code, a starter kit for what language you want, observability tooling, secrets, containerization, build and test pipelines, deployment pipelines, Kubernetes manifests, and then routing configuration. So for you, you're just providing application logic, web services, those sorts of things. And what these included capabilities sort of look like is a set of files or settings sort of all stored in GitHub. And within that, sort of to dig down a little bit more, is observability tooling is really built on top of OpenTelemetry. Secrets integration is using Vault. Containerization is built on Docker files. The build and test pipeline is using a combination of a tool called Drone, which some people might be familiar with, and Argo CD. The Kubernetes manifests are a combination of Customize and Helm. Digging too much into the weeds, but we've sort of been going through some transitions with this stuff here. If people are interested, feel free to chat with me afterwards. But the idea is that like the GitHub repo has all of this stuff packaged for you in a way that makes it easy for you to manage and for us to sort of provide you updates if we're making changes to things over time. And the sort of the workflow of this template engine is a team comes to a form, fills out a bunch of information about what they want, name of their app, the language, what team they're in, if they want a few like experimental features that we're offering, a Slack channel for them for us to send notification to. They click go. It stores all that information in a Git repo. A Drone pipeline kicks off and then creates this spread of stuff for you. Your own Git repo, Vault policies, entries into our Argo CD instance for deployment to happen, and then things get deployed to the Kubernetes cluster. So this flow is really shown from start to finish through maybe a dev environment. But really outside of one manual gate in place for the cloud account access, this is all automated for them. And once that one manual gate is done, the app is deployed and running. So from a developer's perspective, they've got now a running app with source code, and they can access the URL and hand it off to their product management team to review. And as they sort of write code, they've got this interactive app without having to worry about making any decisions for themselves. So let's talk a little bit about the runtime. So when we were sort of setting this up, we experimented with different setups for our cloud accounts to build our platform. Would we sort of have one big account, different accounts? I think this is sort of a company decision depending on how you're sort of managing your cloud accounts. So for us, we sort of went with the model of having individual team accounts. And that would allow us to group workloads with common business purposes together. It allows team to sort of control their own accounts a bit and let them play around in a dev environment without having to step on each other's toes. It limits the scope of adverse events. It achieves some resource independence and isolation between different teams. And it helps us manage cost because we can sort of see what's happening at any individual account at any given time. And I'll talk a little bit about how this interacts with the Kubernetes platform in a second. The next big decision was from the actual Kubernetes perspective, what do we do with the clusters? Do we build multiple single tenant clusters, like every team gets their own cluster, or do we build sort of single multi-tenant clusters by environment? And I think for this, the question is really how you strike a balance between providing each team its own space and having more cost efficiency and just operational efficiency for the team running them. Having separate clusters for each team can give control and isolation and give teams more autonomy, but it can also lead to increased complexity from the folks sort of operating these clusters. And on the other hand, multi-tenant clusters can offer greater resource isolation, simplified management, and more agility. But this approach requires careful planning and implementation of a few things: security, governance, upgrades. Right, you're disrupting a lot of teams' processes if you're running sort of single clusters. So ultimately, the decision comes down to what works best for your company. But I think for us, advanced too far. For us, we went with the approach on the right, which was a single tenant cluster or single multi-tenant clusters per environment. And I'll talk a little bit about our design considerations. So really, we were looking at network isolation. So it's crucial to ensure that each workload has its own sort of boundaries and isn't exposed by default to other workloads. The next thing is role-based access control. So it's essential to have proper access within the cluster, even though there's multiple tenants in there. Operational agility and flexibility. So how's traffic between services talk to each other? Is it secure, but also there's not a lot of friction when two services want to talk to each other? A policy-driven security. So really, how do we sort of treat the security policies as code and ship things out as needed without putting too much burden on the teams? And then also is just resource management. So how do we avoid overspending and ensure optimal performance. So as I mentioned, we went with the multi-tenant architecture model. It's important to note that no one size fits all here. Our design considerations, I mentioned before, are kind of unique to us. But one thing to mention here is the clusters are controlled by automation, and we don't allow teams to do a few things that you normally would get as sort of an administrator of Kubernetes. They can't create namespaces. They can't change security policies. We built a set of operators over the top of the Kubernetes cluster that handles some of the automation of creating what we call tenants. And a tenant is a one-to-one to a namespace. So this gives them sort of administrative control within their namespace, but they don't have the ability to sort of see what's going on in other namespaces. And we're sort of expanding that operator model to give teams more control as we see needs pop up, or to sort of abstract away some of the network policy automation that might be needed, especially when they're like sort of talking across namespaces. Next, I'll talk a little bit about continuous delivery, and I'm going to not talk too much about our continuous integration strategy. I'm going to focus on the delivery model. So for us, we're really focused, like I mentioned in the beginning, we're using a tool called Argo CD to do all the deployments to Kubernetes. I mentioned before that we were using Drone, which was our sort of all-in-one tool, which I think a lot of companies are probably used to having this sort of like thing doer that Jenkins was filling for a long time for many companies. Some of you may still be using that. And it did everything for you. It ran CI, it built, did deployments. So we're trying to slowly move folks more towards this GitOps model, which is the idea that what's deployed in your cluster, what's deployed in Kubernetes is represented in Git. So in addition to sort of infrastructure as code, this is sort of, Kubernetes as code. And move away from the model of having Drone sort of react and push software out. We're still using Drone for test and build automation, but sort of handing off the deployment model to Argo. And I think this has a few advantages. Argo provides sort of a paradigm to do more advanced deployment strategies like Canary and Blue-Green without teams needing to write a bunch of YAML sort of in their own way of how to do all these different strategies and see sort of drift over time between teams. So what is GitOps for folks who are not familiar? It's an operational framework based on DevOps, which automates infrastructure and manages software deployments. And it enables developers to store the desired state of their infrastructure and use it to automate operational processes. So the nice thing with Argo is that you can set it to do sort of this self-healing model. So if someone goes in and accidentally deletes something in Kubernetes with kubectl, Argo will resync and redeploy your application so it maintains what's in Git in the cluster. And some of the goals is to have a centralized CD software delivery platform, pave the way for some of those advanced deployment capabilities I mentioned, offer predefined workloads, best practices, and adopt common workflows across the company. So where's the portal? So as I mentioned in the beginning, we have really focused on getting the platform pieces right. And I think that was just based on the fragmentation that we had with workloads across different clouds and seeing all the practices with deployment. So we were focused on reducing the fragmentation and getting folks sort of all on board in one place. But the portal has sort of popped up recently, and we are using Backstage like many companies are, I think. But we were really focused with Backstage on it solving service catalog problems and documentation, those sorts of things, not necessarily being a portal user interface for our entire platform. The one area that we are using it now, though, is that form box has become Backstage. So we've built basically a plugin in Backstage that automates this workflow for engineers and sort of moved away from, we were using Google Forms before. And that's provided us more flexibility and the ability to do things in JavaScript that you just can't do in Google Forms. And we're sort of like tiptoeing into what could be next? Do we sort of continue investing in Backstage and make it our developer portal, or do we sort of look elsewhere? Whether it's open source or a vendor tool, we're sort of in discovery mode of what does our portal need? What's our platform not providing that the portal needs? Because I think what we want to avoid is just throwing a bunch more UIs on top of it, given the fact that developers already have 5 or 6 things to look at. Okay, so I'm going to transition away from sort of the technical things and talk a little bit about product management. Before I do, I wanted to give a quick shout out. My product partner who wrote most of these slides and gave most of this talk with me in the past could not be here, but I wanted to give him a shout out. His name is Danny Cassidy. We have some product people here from the Times too if you want to talk with them afterwards. So yeah, I'll do my best to pretend to be a product manager for today. So what is platform as product for folks who aren't familiar? So this is really how product thinking can help organizations build and evolve their platforms. And this is a quote from the ThoughtWorks 2021 Tech Radar. They were seeing sort of platform engineering and product teams become a sensible default, with the key insight being that they're just another product team. I think someone mentioned this before. I think maybe Justin mentioned it. You're building a product for users. They just happen to be in your company. So you really need to think about it just like building any other product with product management methodologies. So, product management itself, if you're not familiar, is really at the intersection of business, user needs, and technology. I think Justin had a slightly different Venn diagram for where this fit before, but all these sort of paradigms work. So I'm going to take you through a little bit of our journey. So we started in 2021 with the discovery phase. And that phase was really mapping out the opportunity space. So we conducted user research to understand the current needs and pain points of engineers at the times. We then synthesized that feedback to understand where platform centralization made sense and where it could really drive customer needs and business needs. So the idea here was like understanding where we can scale leverage. So let's look across these various domains that we know developers have challenges with. So CI/CD, observability, traffic routing, runtime, and reliability or monitoring. So that kind of maps back to that overall picture I showed earlier. So this diagram illustrates the themes we uncovered across our core technological domains. It's to note here is that there was discrepancies in this user discovery. And this signals that we were dealing with multiple different types of personas in the company. Some folks really care about simplicity and standardization, but some want the freedom to sort of go outside of the box and not necessarily follow the path. So how do you strike the balance between those two things? We want to sort of build for the 80-90%, not for the 10%. And where are those outliers? So next, we really wanted to align on what the first MVP of our platform would be. And we have this yearly thing called Maker Week. It's sort of a hack week, which I think is common in a lot of companies. So we decided to launch our MVP for Maker Week. So what was sort of the thinnest slice of the platform we could make for our customers to sort of validate some of the understanding and some of the discovery we did? And how do we sort of incentivize feedback at the end of the hackathon so we knew that we were getting valuable feedback from people who actually tried the tool out? And then after we sort of ran that MVP, it was a success. We had a lot of people try it out. And we took a lot of the feedback that we got and started thinking about, okay, how do we get to sort of a GA launch where we can make the platform available for anybody to use if they want to? So the graph on the left represents the diffusion of innovation theory. This really explains how over time an idea or a product gains momentum and spreads through a specific population. So as a product team, the goal is to figure out where in the organization are the innovators, where are the early adopters who'll be more willing to sort of engage in this early phase. And you really need to find a few teams to be these early adopters who are excited, what a developer platform can look like, and how it can help deliver their goals. So the idea here was to make our platform compelling. So find enthusiastic customers. In many ways, our platform was competing with many other tools that engineers at the times were already used to using that were sort of serverless or didn't have any YAML, and we were sort of starting maybe a few steps back. We don't have a 1,000-person development team to build something that necessarily could compete with some of these other tools. And we were really looking at how do we offer value to users that they can't find elsewhere. So there are a small set of capabilities that could create a lot of excitement. So in that feedback synthesizing, we were getting a lot of signals from various places, from Slack, from emails, Hangouts, meeting with people live. So we really need to figure out how do we collect all that feedback and reason about it and synthesize it in a way. And we came up with this idea of centralizing, transparent for everybody to see, and actionable via synthesis. And that's using this tool called a rainbow spreadsheet. It looks something like this, where you're sort of taking all that data and putting it in a spreadsheet so it's visual, and you can identify strong and weak themes based on this user research. So it brings sort of a quantitative layer of qualitative feedback by offering this sort of heat map with the different colors to understand sort of common trends. And we also came up with this capability maturity model. We had a lot of people in the org sort of referring to the platform or their specific component as beta or alpha or POC. And it was creating some confusion of like, what does that really mean? So we borrowed some of this largely from what Google uses for their features. So the idea is you have these different phases of POC, experimental, dev preview, and GA. And we sort of mark each of the releases of various components or various features through the system as they kind of run through these phases. I won't read all of that, but the general idea is POC is something we're sort of validating, used internally by us. Experimental, we release to a few users. Dev preview is like anybody can opt in, and then GA is fully featured and available for everyone. And lastly, so where are we at now? How are we sort of getting across this chasm? So the idea at this point is to scale it to everybody so it can support the majority of use cases. So going back to this diffusion of innovation graph, the chasm really represents the shift in mindset you'll face from the organization or the set of users, where you kind of have to convince not just the enthusiastic people, but even the pessimists, or people who are resistant to change. How do you get them on board? And so that the greatest point of peril is really in that market shift between getting past just the early adopter phase and onto early majority. So for us, I think we've been largely successful with that. Like I can't say actual numbers, but the biggest parts of our org are now running on our platform. We went to, in the timeline I showed this, we went to GA last spring in 2023, and we've really seen tons of traction with people being excited to adopt it and just get out of the business of running their own infrastructure. And really that required a shift in strategy and marketing, a shift in mindset. So how do we think about how you can scale confidence and trust in the platform? For us, it was really getting sort of big teams and big users on board and highlight user success stories on the platform, either through like all hands or just general sharing of information as you kind of see these success stories come up, and invest in quality and operational excellence. So with that, let me just wrap up since I only have 59 seconds left. So make sure you're rooting early architecture decisions for your platform within the context of your company's business needs and your tech org. Sort of make sure you're combining the business and culture impact. Platform as product, I think, has definitely been huge for us. Like having an embedded product team has been great. I know some companies don't necessarily have that format, but I think for us, partnering with engineering and product together has been great. Focus on the users and the business. And what worked well in early adoption phase may not necessarily work well when you're scaling out to the majority. So consider shifting your strategy and marketing investments around to help scale confidence and trust in your platform. And with that, I will wrap up. 12 seconds.
You were talking about you taking that template and then someone can spin it up and they get the the application ready and all of that. And then you said that you provide updates to that. I was wondering if you could expand on how you provide updates through that.
So that is sort of evolved in the couple of years that we've been doing this. But the templating tool works by taking the outputs of that form, which is represented as a JSON document, and then running some automation that uses a templating tool to apply the templates to a repository. And let's say you have repository called foo or whatever with your Go app in it. You're allowed to change all the source code. All of the files that were sort of templated out by us, you're also allowed to change. But if you go back to that form and just resubmit it, we'll re-template out everything with the new updates, and we'll open a pull request on your repo with all of the new changes. There's definitely been some friction in that because the more people sort of drift away and the longer it's been, the harder it is to sort of adopt some of that. But there's some ways that we're sort of trying to mitigate that friction over time. I mentioned the customized Helm piece a bit. We've extracted almost all of the YAML out of people's repositories and moved it to a Helm chart. So that's like one fewer thing that they have to manage. It's just versioned and they can pull it in. The other thing we've been looking at recently is the idea of Git of a three-way merge, so that if they change stuff in the file and we rerun the form and try to open a pull request, it's not going to touch anything that they changed. It will only give them a diff of something that we changed. And we're sort of slowly trying to pull more and more stuff out of the repository as needed, so that anything that we manage that they shouldn't even need to touch shouldn't even be in the repository at all.
Cool. Yeah. Thanks so much.
One more.
Yeah.
Right here, look at
Hey, congrats on getting your portal up and running.
Thank you.
And on crossing the chasm. So my question is, in 2024, or maybe beyond that, right? How are you able, or how have you been convincing, your finance folks to continue investing in developer portals?
I think that goal that I said, like use technology to propel our growth, or I forget, I should know what the phrase is by now, but I think the undifferentiated heavy lifting for teams that are worried about, from the platform side at least, maintaining their own infrastructure and the sort of cost spread when everybody's managing their own infrastructure across various clouds. Now that we've sort of shifted everything under our control, it's our billing, we're managing it with a cloud cost tool. So it's sort of easy to see like, okay, we've saved this much money over time because we used to spend X money on this cloud. It was spread across all these various accounts. Now the runtime spend is under our control. It's easier to sort of do small optimizations. The portal side, in terms of saving money, I think is still up in the air for us because, like I said, we're using Backstage, but we're not investing too much yet in like a true portal solution. We're still trying to figure out where is the most need. Is it like going into the portal to do operations that people would normally do in something like GitHub today? Is it documentation and discovery of services and APIs? Like where is the portal going to serve the most need before we make a big investment?